It's okay. Aman, can you hear me well?
Yeah. We can. I can hear you. Yes, thank you, Dr. Ashraf.
Okay, thank you.
Yeah, you can share your screen and you can start. Yeah, and thank you for your time. And I know this is a very interesting a topic from Dr. Ashraf. He is going to present about blockchain technology and applications. Thank you, Dr. Ashraf, about this.
Thank you, Amar. Thank you for giving me this opportunity to lecture in your class. It's always nice of you, actually. You managed opportunity for many of us. And thanks for your nice teaching also. So, hello, everyone. I am Ashrafuddin. Recently, I completed my PhD in the field of cybersecurity from Internet Commerce Security Lab at Federation University, Australia. So today I'm going to discuss blockchain and digital forensic. First of all, I will cover the basic of blockchain. Otherwise, we can't understand the implication of this technology in blockchain. To understand the application and implication uses of this technology in digital forensic or in other field like e-health, e-cash, and also vaccine supply chain distribution. In many cases, we are trying to use the blockchain. Although in all of the cases, we should not think of blockchain to apply because it has also some negative aspect also. So however, first of all, I am going to cover this basic of blockchain. So before describing the blockchain and this technology, first we need to know how actually blockchain has been popular. So in the old time, we know that there was no currency systems. People used to exchange their goods to get another type of service or to another type of goods. For example, by exchanging wheat, you could get the lamb. But in modern time, we exchange currency, we exchange money to have any service, to get any service. So now the traditional system in exchanging money or to buy something, we always depend on the banking systems. For example, Alice want to send some money to Bob. What Alice will do? Alice first issue a command to give some money from her account to Bob account. So Alice will give the bank a permission to give this money. The bank will verify whether Alice has more than $5 or not. If Alice want to send $5 to Bob, then first of all, bank will verify if Alice has the $5 or more than $5. If Alice has more than $5, then bank will send $5 to Bob, and $5 will be deducted from Alice account. So in this way, in normal banking system, we know that all kind of our transactions are being performed. So what's the advantage of this system? The advantage of the system is digital payment. We don't need to give someone some cash money, don't need to meet them in person. So this is the advantage. Another advantage is that we can depend on the bank that our money will not be misused. But there are a lot of problems here. The first of all, not a peer-to-peer transaction it is. What does this mean? This means that bank knows everything about me and also about the receiver who is receiving. There is no privacy here. And another thing is bank is a single entity. We can have many banks, but when we open an account in a particular bank, then that bank is a single entity for maintaining our account. If it fails, then everything is failed. Perhaps until it resumes, we can't send money to our friend. We will have to wait. And sometimes, if we would like to send some money, then bank sometimes censor this transaction. Bank sometimes does not allow this transaction to be happened because it may be suspected transaction. There are many reasons. And another thing is if you would like to hack someone's computer for good reason, for example, or if you would like to claim some money for someone illegally, although it's not right, but illegally, then you can't perform the transaction through bank, because bank will know who you are going to commit a crime. So that's also not possible using this current banking system. So that's why researchers come to a solution. They introduce a cryptocurrency. Already this cryptocurrency is known to everyone, I think. This cryptocurrency stores everything digitally, and here there is no central authority. No one is supervising our transaction. We don't need to depend on someone to allow our transaction to be happened. Here, our transaction is secured with cryptographically, and it's called a distributed. Here, a distributed consensus mechanism work. Also, people can have some incentive if they join these cryptocurrency systems. So what is the magic behind this cryptocurrency? This is the blockchain. That's the magic behind this cryptocurrency. So now we are going to describe the basic of blockchain, because this cryptocurrency is built on top of the blockchain. Without blockchain, we can't imagine any cryptocurrency. So cryptocurrency has some properties we can ignore here now, like durability. It will never be down, and also portability. From anywhere you can use it. Uniformity. Everyone is using the same kind of transaction and same type of system. So not like bank, we know that different bank has different rules. Commonwealth Bank maintains a separate kind of rules, and the bank from another country with different name also maintain different rules and regulation. But in cryptocurrency, the things is not like that. So okay, let's discuss about the blockchain. Before blockchain, we like to tell about something Bitcoin. The Bitcoin first cryptocurrency that perhaps we have heard the name of Bitcoin. Next, we have also heard the name of Ethereum. That's also another popular cryptocurrency systems. So this Bitcoin, we know that was introduced in 2018. Then from 2009, it has been popular. Everyone started investing their money in this cryptocurrency technique, and also started investing their resources. Two kind of things we can invest in this cryptocurrency. One is you can invest your money like the share market, and you can sell your currency to someone else at higher price. And another thing is you can earn money by investing your computer resources. Already you know about it. So this cryptocurrency is called a peer-to-peer electronic cash, and blockchain basically has been popular from this cryptocurrency system. But blockchain itself was introduced long time before. That time we haven't heard the popularity of this technology, but nowadays it has been more popular. So, however, if we would like to define the blockchain, then we define a blockchain as a distributed secured ledger on multiple computers. And this ledger is shared with every participant, and this ledger will be stored in every computer. The complete ledger will be stored on every computer, and every participant can access the ledger, and also the transaction that will be performed on this system will be anonymous. Like the owner of the transaction will not be disclosed to anyone. You can't know who is this person, who is this person. So blockchain, to run any system, we need a network. So P2P network, we'll discuss later what is P2P network, P2P or peer-to-peer network. So blockchain technology runs on a P2P network, and blockchain maintains a distributed database. Sometimes we say the database, sometimes we say that ledger, and this database, the complete database, will be stored by every computer in the network. So what's the difference from traditional distributed system? Blockchain is also distributed system, and already we are also familiar with the distributed system. So what is the basic difference between this blockchain distributed system and normal distributed system? In normal distributed system, if we say that data are distributed among different computer, so we mean that not the complete data, not the complete database distributed among all of the computer. Perhaps data has been partitioned in different parts, and different parts are actually stored in different computer. But in blockchain technology, the complete ledger is stored in every computer. So that means if some of computer is down, still can have access to my complete ledger or complete database from any other computer. So it's not practical that more than 51 computers will be hacked by one. I mean that more than 51% will be convinced in the network by someone else or a hacker. It's not possible. Or maybe all of the computer will be down by something. That's not practical. That will not happen. We at least we can assume that, or mathematically we can prove that. So that's why blockchain is considered so much secured. So in this slide, I'm just showing you every part of a blockchain technology, how a transaction is being passed through blockchain and how a transaction is being committed in the blockchain. So blockchain, sometimes we say that it's a database, but it's more than database. The reason is it operates on a P2P network. The P2P network that I have actually shown here, we can see that this P2P network means that all of the participants are interconnected. Every participant is connected to everyone else. So anyone can send data to anyone other. For example, this computer can send data to here, every other computer. So this is called the P2P network or peer-to-peer communication. They don't need a central entity to send their data from one computer to another. Here they can directly communicate. So this is the P2P network. So the blockchain run on this P2P network, and this node stores the database or shared ledger. Sometimes we say that list of chain or chain of blocks. From the blocks terms, blockchain has came. So this all of the node will contain the chain of block. So when chain of block is being produced from the transaction, this chain of block is produced. What does this transaction means? The transaction means the people who are using this blockchain technology, they are making transaction. When they send money to someone else, then a transaction is being produced. When they mine something or they earn some money from a blockchain, then a transaction being produced. So thousands of millions of users are using this blockchain, and millions of users are producing the transactions. So like that, here we are assuming that L is one of the user. L is wants to send some digital coin to Bob, perhaps her friend. And what L is first will do, L is will create a transaction, and this transaction will be sent to this P2P network. And this P2P network consists of some computer. And next, the computer that will first receive this transaction will broadcast this transaction throughout this network. That means all of the other computer will get this transaction. Next, what will happen? Next, this computer, they will organize the transaction into a block. So you can say that this is only one transaction, and like the Alice, someone else also are producing the transaction, is producing the transaction. So a certain number of transaction, for example, 1024 number of transaction will be organized, will be packed in a block. Then that block will be verified by each of this node. So all of the, so what is happening here? First transaction are producing in this network. Then some of the node or maybe all of the node, or maybe one or two node are making the block by taking certain number of transaction, and next they are broadcasting that block among this network, and every node just verify the block, whether block is okay or not. So what kind of verification are normally being performed? We will discuss it later. So for example, now you can assume that all of this node uh, is saying that, okay, this block is okay. This block has no problem. So this is the confirmed block, verified block. Now what will happen? This block will be added with the already existing block, because 10 minutes before 10 minutes, this network also produced some block, and 1 year ago they also produced some block. So all of the blocks till now what will be produced in the network will be interconnected, will be connected in a linked list fashion. That means this node will contain some address of this node, of this block, and this block will contain the address of this block. This block, this newly created block, will contain the address of this block. So in this way, they will create a linked list. They will be linked. So we'll later discuss what does this address means. I have told you that, okay, this block will contain the address of this previous node, of sorry, not node, of this previous block. So what does this address means? Address means this is the memory address. No, actually not address, the hash code. This block will contain the hash code of this previous blocks. And also this block will contain the hash code of its immediately previous block. Similarly, this block will contain the hash code of its previously committed block. This way, they will create a block. So this chain of block will be contained by this node, by this node, by this node, by this node. Every node will store this node. Later, the Bob who has a transaction in this blockchain sent by the Alice can access using his private key. So here we have actually mentioned a term, private and public key. So this we'll briefly just describe later. But if you would like to know detail about the cryptocurrency that has been used in the blockchain, you need to study further. So this is the basic operation of a blockchain, particularly in a Bitcoin blockchain. What is happening? We have just try to show you in this slide. So here there are many things to discuss, like in the consensus mechanism. I have told you that they reach an agreement that, okay, this block is okay. So how they reach this agreement? So there a consensus algorithm will work. There are many consensus algorithms that you can use. So there is a discussion. And also here we can see that this is a P2P network. There is a variation of the P2P network that we'll discuss in the next slide. And also in this case, we have said that this is the chain of blocks. That means every block contains the hash of its previous block. But there are other structure also. This is the linked list structure. There is also DSG based structure. So how DSG based structure works? Whether the DSG based structure is faster than this linked list structure, there are many questions. There are many research areas that we will discuss later. And also how we can use this structure for preserving our digital forensic things, that also we will discuss a little bit. So there are some basic characteristics. Always we say that it is decentralized control because there is no single entity that will verify our things. Here is also verification, but it's not assigned for only one person. Here every participant in the blockchain verify the block. So I don't need to depend on someone, only single entity. Tamper evidence. How you will tamper something or some document here? Because every node here is maintaining this chain of block. If you sense the content of a block, then the hash code of that block will sense, and it will be reflected in the next block, because the hash code that next block is containing will not actually match with the sensed hash code of the previous block. So you can't tamper anything, you can't sense anything. If you would like to sense, then you need to sense the complete chain of block, or you need to recompute the hash of every block here. So it's not possible to change anything. Another is that Nakamoto consensus. This is called proof of work. We'll later discuss that if you would like to update any blockchain, like if I would like to recompute the hash, then it involves a lot of time, and also it needs a lot of time. It involves a lot of resource. You need to invest a lot of resource. That's not possible for 1 or 2 person to invest that amount of resource to change the hash, because here the hash does not mean that only single hash. This hash means actually target hash. What does target hash means? Like I will have to produce a hash which contain 17 zero at the beginning, or as the leading it should contain 17 zero. So if you put something in a hash function, then you will produce a hash code, that one iteration, one time execution, but that hash code will never contain 17 zero as a leading position, or as in the beginning of the hash code. It will never contain 17 zero. So that means you will have to operate the hash function repeatedly, maybe million times, billion times, then you will come up to a target hash. So that's why you need to invest your CPU time, and it will also take a lot of time. So that's why it's not possible to hack something, or to tamper something, to change, to modify something in the blockchain. So we always know that what centralization. Before studying blockchain, we understand what is centralization and what is decentralization. I like to just skip it. You also know that what's difference, what's the advantage, disadvantage centralization, and what's decentralization. As blockchain is a decentralized system, so perhaps you can just know about decentralization. If you already are not knowing, then you can only. Okay, here are some decentralization advantages. I like just to skip these things. Now I like to actually describe blockchain a bit detail. Not much details. I'll be also very quick to describe these things. In this lecture, I will describe the blockchain protocol, and also I will show you where you can do some research to improve the current blockchain. Or if you would like to adopt your blockchain in a particular field, like IoT field, digital forensic field, e-health field, and also gun control field, vaccine distribution, and vaccine recording field, then how you can sense the blockchain, current blockchain technology, or how you can use the some enterprise blockchain to serve your purpose, that I will be discussing in this lecture too. So let's recap our previous things. In this slide, I also just put how blockchain works. I will not be discussing it. Already, I think you know that how blockchain is working, like the basic, just how it works. It's the repetition of the previous slide. Okay. So now we'll see how actually blockchain is described in different book or maybe research paper. So blockchain can be defined using some layers, 4 or 5 layers. This differs. Some book describe it using 5 layers, some book 4 layers, and also the name of the layers are different. So this is somewhat similar to network TCP/IP layer. We know that network TCP/IP layer has the 5 layers, but that's established layer. This blockchain layer description is not established like that TCP/IP layer. And also network is a very broad topic. This is just a technology. This technology borrow technology or method from other fields, like from cryptography. Sometimes we describe blockchain as a combination of cryptography, computer science, and also game theory. So this blockchain sometimes are called the combination of game theory, computer science, and cryptography, although cryptography fall under the computer science, but you can separately say that. But here I am describing this blockchain based on layer. So before that, I think everyone is hearing me and everyone is understanding me what I have already discussed. Just can you help me? Everything is okay till now?
Yes, all good.
Okay, then nice. You can ask question, you can stop me when I will be delivering lecture, you can stop me. That's if you are not clear about anything. If please do that, then we can understand. Okay. So let's start the definition of blockchain based on the layer basis. So in many research paper, we say that the first step of developing any blockchain is to fix what kind of um, execution environment you need to set up, what kind of tools, what kind of software you'll need to develop this blockchain. So in the bottom part, in the bottom, we can see there is a layer. This is called execution layer. In this execution layer, um, just our computer setup. Like we might need VM, virtual machine, or we might need compiler, some compiler, Docker. So these are not directly related with the blockchain. These are making our computer ready for developing blockchain. So this is called execution layer. And the top of this execution layer, another layer is network layer. Okay, this layer has something with blockchain because our traditional network will not work here. We will have to create a P2P network, peer-to-peer network. The peer-to-peer network, just a network here, we have shown here, a P2P network. We can see that every node is connected to every other node. Like they can communicate to each other. This is called P2P network. And we know that the torrent also maintain a P2P network. Finally, you would like to download something from the torrent, then the node that has the data or required data, that will send the data to me directly. There is no media or via in between me and the sender. I am the receiver and another one is sender. So no immediates. The blockchain also maintain that kind of P2P network. And another is the variation of P2P network is the sharding. This sharding we'll discuss later. Just we at this moment we will just know that it's the variation of. And D is the directed acyclic graph. That's also fall under this category, but sometimes DSZ is also linked to another layer. However, DSZ, that means directed acyclic graph. We know that this is also indicate a structure that indicates also a topology. So that's why whenever we say about the network layer, then we mention about the topology. But here, not only topology. To run the P2P network, you need some particular protocol that we normally study in our networking. TCP/IP for the transport layer, and also the IP that for the network layer in the internet. But here we could give the different name, but all of the networking things will be discussed here. And another important layer that's are fully related to the blockchain. That's called the consensus layer. So this consensus layer will actually will be needed to verify or to commit any transaction in the blockchain. If we produce any transaction, our transaction will not automatically included in the chain of block in the ledger. What will happen before that? Some node or all of the node will reach an agreement about the validation and correctness of any block. So this is called the consensus layer or consensus protocol. So there are many popular consensus protocol in the Bitcoin. We already know that proof of work. This is a consensus protocol. Using this proof of work, blockchain node will reach to an agreement about a block, about the correctness of a block. Another time-saving protocol is called the proof of stake. The Ethereum blockchain, the current Ethereum blockchain is going to use the proof of stake. Another one is called the practical Byzantine fault tolerant. This also the variation of the Byzantine practical fault tolerant. This is the variation of basic Byzantine fault tolerant problem. So this basic Byzantine fault tolerant is not also a new concept, but it has been actually used in the blockchain technology to reach the consensus. We'll not maybe cover this protocol here because we don't have much time. But we'll have some discussion on proof of stake and proof of work, how these two protocol work. And another important layer that's on top of the consensus layer. Without this layer, we can't actually do anything. This is the basic layer. That's called the data layer. We just give a name, data link layer. All kind of transaction and the block structure will be discussed in this layer. And also how we'll provide security to the transaction or block, that will be also discussed in this data link layer. So this data link layer deals with the structure of transaction, deals with the structure of block, and also the digital signature. Digital signature is one of the important part of blockchain. If you would like to confirm the confidentiality, authenticity, then you need to use the digital signature. We'll later discuss where this signature has been used. And on top of everything, this layer we call the application layer. Most of us who would like to actually develop any application using the blockchain, then we'll work on this layer. If we would like to develop in mobile apps for recording the COVID result, COVID negative or positive result, or if you would like to maintain COVID-19 vaccine distribution information, then we can develop an application. And the application that are developed using the blockchain is called the decentralized application, or sometimes we say that DApps. So whenever when we say about application, then application has also other things, like application should have an user interface so that user can interact with the application. And also this application need to interact with the blockchain, as it will keep the record in the blockchain. So how it will interact with blockchain? Smart contract. This is mostly related to Ethereum blockchain. Not actually Ethereum blockchain, other blockchain also are using smart contract, but mainly first we have heard the name of smart contract from Ethereum. Before introduction of the Ethereum, smart contract is also there, but that would be maintained by a centralized body or central body. But nowadays, the smart contract is being deployed and also maintained by blockchain. And a smart contract is nothing, just a set of programming instruction that are inserted or that are deployed on the blockchain. We can compare this smart contract with the function of database. If you are a student from computer science, I think, and if you are studying the database, then in database system, we could initiate trigger. Like we could write a program in the database, and if something happen in the database, then that certain line of code would execute, and then it will perform something. So this is called the trigger. In normal database system, we used to use trigger. Smart contract is similar to that trigger things, but the difference is that a smart contract will run on the blockchain and it's not centralized. Another term is, we can see that chain code. This chain code, this is also the smart contract, but it comes with a different name. Why? Because another popular enterprise blockchain is Hyperledger Fabric blockchain that was developed by IBM, and many users nowadays are using Hyperledger Fabric also for developing their application. So in Hyperledger Fabric, they called the smart contract chain code. They normally call the smart contract chain code. So what is a smart contract? A smart contract is a program, and this program will be deployed on the blockchain, and this program will help us to interact with blockchain using user interface. So this DF use this smart contract. So in this slide, we have just described what are different layer of the blockchain. You may add one or two more. So let's discuss about the data layer. As we know that the basic unit or basic data structure of the blockchain technology is called the transaction. So this is the basic data unit structure, transaction. So this transaction normally contains some information. We are discussing transaction block with the context of Bitcoin. But according to your application, the number of field in the transaction or number of field in the block will change. If you develop your own blockchain, then that will have a different number of field as you like. So now we are just describing a standard transaction structure. So a transaction that will be produced when I would like to send some money to someone else, then the transaction will have sender address, my address, and my private key. Sender private key, here it's wrong actually. My private key, not my private key, it will be my public key. The reason is private key should not be disclosed to anyone. Public private key infrastructure, we know that there are two key in a pair. One is called the public key, another one is the private key. As a person, I will have this pair. I will not share my private key with anybody, but I will share my public key to anyone who would like to know my private public key, or with whom I would like to share my some data. Then I will send him or her my public key, but not private key. So it's a bit wrong. Another one is a recipient address and also the amount that you would like to send someone else. So first of all, here we have, we can see that someone is producing transaction. So this is the structure of the transaction. Then the transaction will be packed in a block. This such kind of block may contain 1024 number of transaction. Or if you develop your own blockchain, then it depends on you how many transactions you will include in a block. It depends on you. And structure of a block, in the block heading, a block normally has two parts. One is called the headers, another one is the data. In the data part, all of the transaction will remain, but in the heading part, we can see that hash of the previous block, there is a field. Another field is timestamp. That means when this block was created, that time will be put here. And another one field, we can see that nonce. This nonce field, we can see the uses of this nonce field in the consensus layer. So this nonce normally used in consensus layer are being used by the consensus protocol. So we will discuss it later. And also another field, that is the hash of the block data. That means the data that the transaction or the data that this block will contain should have a hash code, so that we can verify later that the data has not been changed. So that's why this one will also contain the hash of the data. So this is the structure of the block. So I am repeating again that this kind of block does not contain just only transaction. They contain many transactions. We just see here only one, but that does not mean that only one transaction it contains. So this is the task of data link layer. And here just we give the definition of hash. I think all of you already know that what is hash. That hash, this is a computer science function, cryptographic function that takes an arbitrary number of length of data and then produced a fixed size of code. If we say that we will use the SHA-256, so that means that it will produce a code which size is 256. So if I put all of this text in this into this function, then it will produce a 256 code. So this is called the hash. That hash we are discussing in the blockchain. Hash is very important for blockchain. So another important aspect in blockchain that in blockchain data block, we'll say that already we mentioned that the block contain transaction. So how actually it contain the transaction? I mean, how it store the transaction inside a block? Block normally contain a marketability, and this marketability is produced from the transaction. How this marketability is produced from transaction? Let's say, for example, this block will have 4 transaction. We'll only have 4 transaction: T1, T2, T3, T4. T1 is produced from you, T2 is produced from me, T3 is produced from someone else, and T4 also someone else. So all of this transaction will be kept in this block, in this current block. This is our current block. So what blockchain node will do before making this block? They will first generate a marketability. How this marketability will produce? Let's see. So first of all, the hash of transaction T1 will be taken. So for example, or assume that S1 is the hash of T1. Similarly, hash of T2 transaction will be produced, and this is the S2. And similarly, T3, hash of T3 is S3, hash of T4 is S4. Next, these 2 hash will be merged or concatenated, and the value of this S1 and S2, or the content of S1 and S2, will be put into another hash function. And that hash function, the hash code is S5. Likewise, S3 and S4 will be concatenated, and this concatenated value or code will be put into hash code, again hash code, and S6 will be produced. We just give a name. At the next time, S5 and S6 will be also concatenated, another new hash code will be produced, and that hash code will be put into a hash function as a content, and we will get another hash code, that's the ACE. Now, by following this step, we come to a root hash, hash. So this hash is called the root of the marketability, and this whole process, the whole tree, is called the marketability. So this is actually the binary tree. If we are the student from computer science, and if we study data structure, we know that this is actually binary tree. So marketability is one kind of binary tree, and this binary tree produce a single hash code from all of the transaction, and this single hash code will be produced and will be kept into this block here, hash of the block data, and also the here root of the marketability here. So there will be list of the transaction T1, T2, and also the root of the tree. So what's the advantage of this tree? Why blockchain use this marketability? The reason is, if you sense any transaction, then again, if you produce the root of the marketability from the sense transaction list, from the sense list of transaction, then the root that was produced previously will not mess with the current one. That way you can verify, and also easily can be verified. Like, you don't need to go to the level of root. In any level you can verify. Like, if I sense this one, then at this stage maybe I can understand that okay, it has been sensed. And also, if T1 has been sensed, then just I need to produce the hash for this part, not this part. No need to produce hash for this part. We can just save some time. So this marketability actually ensure the integrity of the transaction. The transaction that will be packed in a block, you can ensure the integrity of this transaction using this marketability. I don't have much time, otherwise I could also show you the code, computer science code, that Python code, to generate this marketability. And also I could show you that how you can verify if any transaction has been sensed or not. I don't have much time, that's why just skipping these things. So next, you already know that what's transaction, what's the block, and what are the different field of the block. Now, how block are actually linked to each other. The thing is, blockchain does not only produce one block. They produce million billion number of blocks. In blocks in Bitcoin, every 10 minutes a new block is produced. So how this block is stored in computer in every participant of the blockchain, in every node or every computer of the blockchain. So this is the way how they store blocks in as a ledger. So this is the technique. For example, this is the first block, and the first block is called the genesis block. When any new blockchain start, like when blockchain, Bitcoin blockchain started, then a genesis block was produced. This genesis block will not have any transaction. The reason is this is the first block, and this is the second block. For example, just assume this is the second block. So this second block, what this second block will do after this second block is being verified by every blockchain, then every node of the blockchain, then every node will join this, will link this block one with the genesis block this way. So this is the way. What we can see that this block is containing the hash of this genesis block. And assume that this is the block 2. This block was produced after 10 minutes of this for block. Then after verification process has been done with this block 2, then every node will include this block 2 with their already chain of block in this way. How? This block will contain the hash of its immediately previous block 1. So hash of this. And here we also can see that how the transaction will be stored in a block. Already we discussed this thing. So in this here I just put a block same node and try to make you understand that this node will contain this chain of block. But not only this node, all of this node will contain this. So this chain of block will be the same for all of this node. So this way, for this reason, we call the chain of block or blockchain. So this is the thing. So now we like to discuss about the properties of public-private key. So suddenly we came to a new topics. The reason is we just skip one things, that is digital signature. Even in this structure, we skip the digital signature. Every transaction will have the digital signature of the sender, but here we did not mention it. Even we haven't write it. It's just not the full scenario of a block or of a transaction. So that's why we just missed this point. So I am repeating again, every transaction will contain the digital signature of the sender. Otherwise, how blockchain node will verify that this transaction was introduced, this transaction was made by from someone? How we can verify that? The blockchain need to verify that. So the digital signature will help that to verify that. So in order to create the digital signature, we need a public-private key. Every participant in the blockchain will have a pair of public-private key. And the properties of a public-private key is asymmetric properties. That means they are two different keys. They are not identical, but if you encrypt your document using public key, then you can decrypt the document using private key. Reversely, if you encrypt your document using private key, then you can decrypt your document using public key. So this is called the asymmetric properties. So these properties will be needed. These properties will help us to generate the public key. That's why just here we discuss the opposite key that is not employed to encrypt the message from the pair is utilized to decrypt the message. Okay. Now let's see how digital signature works. We will just cover it brief first. Perhaps most of us already know that how digital signature is. For example, this is the sender who is producing the transaction, and this transaction will be sent to the receiver. So the transaction will have the digital signature of the sender. How a sender will produce the digital signature? For example, this is the message. This is the content of our transaction. So we just named it here message. So first of all, this message will be put in a message digest function. That means hash. It will be sent to hash. This hash, the hash function will produce a hash code. This hash code we are giving here name digest. So this digest, this is the hash code actually. So this is hash code. Now what we'll do, we will encrypt this hash code using the private key of the sender, and we are calling it signature. So when this sender will send the message or transaction to the receiver, what the sender will do, this sender will include this signature with this original message. So this is the signature, or this is the encrypted hash code of this data, of this message, of this transaction. And this is, we are calling here that this is the transmitted data. So the receiver will receive the transmitted data, and what receiver will do now to verify this signature? Receiver will take the public key of the sender, and this public key will be known to every other participant of the blockchain. So it's not problem. Anyone can know my public key. That's not problem. So this receiver first will take the public key of the sender, and next what it will do, it will decrypt the signature using this public key. Why the receiver will be able to decrypt this signature using the sender public key? The reason is we know that already the properties. Already we know the properties of public private key, that if we use the private key to encrypt a document, then the public key of the same user should be used to decrypt the document. So here receiver is using the public key of the sender, so it will get the digest, or it will get the hash code. Does it prove that it is already verified? No. Receiver will produce another hash code from this message, because this message is not encrypted. Even you can send this message in encrypted format, then it will produce the hash code from this encrypted format. That will be more secure. That's the different issue. Now we are assuming that this message, this is just plain text message. So what receiver will do? Receiver will also send this message into a hash function, and it will get also digest. This digest and this digest should be same, but this is the receiver responsibility whether this digest and this digest same. How it will do that? It already got the digest from the message, and also produced digest from the message. So it will verify whether these two digest are equal or not. If equal, then it will be sure that okay, this message has been sent to this sender. So this way it can verify the digital signature. Here you might have some question that is okay, someone may send this both message and also this code, this signature also, but the thing is only this sender know its private key, and this transmitted signature was produced using this private key. So if anyone actually sends both, then that will not actually work here. The reason is the receiver always try to decrypt the signature using this sender public key. So that will not work. So however, this is the way of the verifying the signature in blockchain. So I have just described this process as the part of the data link layer. because a transaction will need sender digital signature and the receiver on in other word we can say that participant of the blockchain need to verify that whether this particular transaction is actually produced from a particular sender. So every other blockchain node need to verify that. That's the part of the consensus protocol. This verification is the part of the consensus protocol. But this the making of the digital signature is the part of the data link layer. So that's why I have discussed here. And but this verification, this is the part of the consensus layer. So let's now see the network layer. Already we discussed that the P2P network actually for the describing in the network layer, but here I am describing another technique that's called the sharding. Sharding is the variation of P2P network. Sharding partition the complete P2P network into different small P2P network. That means see here, this is a small P2P network, this is another P2P network, this is another, this is another. And there is also the connection in between this P2P group, this P2P group. So this is the complete network has been partitioned. And why this partition has been done? The reason is before a single node need to actually take the load for the complete blockchain. But in that case, the computation load has been divided, storage and computation load has been divided among different group of nodes. So that means one of the node from this group will take the load for this partition or for his or her partition, for its partition. Another node from another partition will take the load or will take the storage, will manage the storage for just its group member. And similarly, other member from other group will take the load for it. So this will make the process faster. Our transaction will be produced or will get the better throughput by using this sharding technique. So this is just variation of the P2P network. In normal blockchain technology, even in Bitcoin technology, we use the P2P complete a only single network, a P2P network. In that case, a node requires to take the load for the complete network. Now we like to describe the consensus layer. This is one of the important layer, and in this layer we can do some research. Like we can introduce new consensus protocol, new validation verification protocol, and even in the network layer here we have also some research that how computation load can be distributed among all of the group so that a fair distribution has been done, and also how many nodes should be in a particular group, that we can also analyze. There is also research. And another research area that I forgot to mention, that we have said that a certain number of transactions are normally packed in a block, but we know that the transaction that will be produced in the blockchain will be kept in a pool, in a storage pool, or in a storage container. So from that container, the blockchain take 1024 transaction and then pack it in a block. So the thing is, which 1024 transaction I will take at this moment for the current block. So there is a research. Maybe you can set the priority. I will take someone's transaction whose job is very urgent or who give me some money. So there might have many criteria. There is also research. And also the research is how many transactions should be packed in a block. That's also research. If you take many transactions, then it will overload your network. When the block will pass from one node to another node, then it will create the congestion in the network. So that's the things. If you take the less number of transaction in a block, then maybe frequent block should be made. So that will also actually create some network overhead. That's why you'll have to do some research. How many should be taken in a block? And also another research is which certain number of transaction will be included in a current block. That's also another research. And here this starting, you can do also research. So these are the some research gap or research area in the blockchain itself. But there we can design many kind of application using the blockchain. And at the end of this lecture, I will show you one of the sample example of a decentralized application, that how we can use a decentralized application in digital forensic, that I will show you at the end of this lecture. So now I like to discuss about the consensus layer. So the consensus layer, already we said that this consensus algorithm are used by the blockchain node to commit, in order to commit a block, in order to store a block in the blockchain. So there are many there are many consensus protocol. One of the popular one is proof of work, and another one is proof of stake. Proof of stake has some variation, like delegated proof of work, delegated proof of stake, leased proof of stake. So there are some variation. Even you can also sense standard proof of stake, and also there might come another new protocol that was developed by you here. Another type is Byzantine fault tolerance, and the variation of this protocol are this. And another one is proof of authority. A new one, proof of elapsed time, proof of bandwidth. So we will not be covering all of this protocol here. We'll just discuss proof of work and proof of stake in the next two slides. If you are interested to do research in a consensus mechanism, then you are requested to read this. You can have this from different research paper. So let's see how proof of work is working in Bitcoin. So this proof of work is introduced by Bitcoin. So in this lecture, I'm trying to show you how it is working. So first of all, assume that the blockchain node now have a block. This is block N. Already blockchain committed all of the blocks up to block N-1. So this is the current block 1. So first of all, every node, here we can see that this is the network, a blockchain network, and there are only 3 nodes we are assuming here. And already this node has a chain of block ledger, and this ledger, this is the last block of this ledger is N-1. So now this is the new block. Whenever this node, and this node will have this block, then what they will do, they will go for a competition. What kind of competition? They will input this block in a hash function. So this is the hash function, and every node, this hash function, and they will try to produce a target hash. And you can see here nonce. So this is a variable. When a node is produced, the value of this variable is 0. If we put this block in a hash function, then a hash will be produced. Again, if we put this hash function in this, put this block into this hash function, then the same hash will be produced. So how we'll come up to a target hash? I already mentioned that target hash is a hash which will contain 17 0 at the beginning of the code. So a hash code is called target hash when the hash code will have a certain number of 0 at the beginning of the hash code. I should have actually shown you a hash code, like a such kind of hash code. I will show you on the Google that how it's just now describing. So I am repeating you again. Every node target is now to produce a target hash from this block. But if I put the same content into the hash function, then same hash code will produce, because this is the nature of the hash function. So what we can do, we have just kept here a variable called the nonce, and this nonce field can only be sensed, not other field of the block can be sensed by any way. You can't sense. So only this field, this is nonce field, this nonce field can sense. So every time we push this block into hash function, we will sense this nonce. In order to produce the target hash, a blockchain node need to repeatedly put this block into hash function and repeatedly sense the nonce field, increment this nonce field to produce that target hash. So we don't know how many times this nonce field is needed to be sensed, is needed to be incremented. We don't know. No node knows it to produce the target hash, how many times they do. So every block, every node here just do this process. They repeatedly just put the block into the hash function, and if they come up to a target hash, that's okay. If one can come off the target hash, it will declare that okay, I am the winner, I got the target hash, and every other node then will stop doing the same things, stop producing the hash function, and they will receive the winner's block, and the winner will get some incentive. So this is the proof of work, how the proof of work here working. So the things is, to get the target hash, every node needs to spend some time. Just first iteration, at the first iteration, you will never get that target hash. We can sense the number of, we can sense our requirement. We can say that, okay, we are interested only producing 40 at the beginning of the hash code, then it will be faster more. If you design your own blockchain, then maybe you can sense the requirement. Currently, the Bitcoin blockchain set a target hash with 17.0 at the beginning, as a leading 17.0. At the currently it set this. In future, it might set more. It depends on the number of participants in the blockchain. If number of participants in the blockchain many, then you need to say increase the target. This is called the difficulty. Okay, I think Dr. Amar want to.
Yeah, thank you, Dr. Ashraf. I think now we have a lab. So I would like to ask the student to join their labs. Thank you for this. It's very great presentation, Dr. Ashraf. Yeah, thank you. Thank you so much. Because we have 3:30, we have the lab. We need to join another link, Dr. Ashraf.
Okay. Then I think I also have a lab. So
you can join your lab. I will end this and I will join my lab. Okay.
Okay. So
yeah, what do you think, Ashraf?
Yeah, that's a good idea. So in today's lab, yes, I will show my student that how blockchain can be applied in digital forensic. That I will show one example.
Yeah. Can you show? So can you show us here?
Yes, I can show here also.
Yeah.
So I think most of the student who will be also attending in the lab are in this class also, I think.
Yes, the same, yes.
Okay. Okay, just I'm going to lab. So will I continue? Just
okay, you can go to your lab. It's better to in your lab.
Okay, just will now maybe that will take only 50. Okay, my lab. Okay.
Yeah, thank you.
So we like to finish this lecture here.
Yes,
I'm
thank you.
just 1 minute. I'm
Yes.
showing the what are the things in this lecture.
Okay, yes, Ashraf.
Yes. So this is the proof of work. How this proof of work work? You can click this link, then you'll have some practical idea. And if you would like to develop your own blockchain, then please click this thing link, and then you will have some idea to develop your own blockchain. And so it's and in this lecture I just described how application layer is working. So in this slide you can know how you can develop your own application using Ethereum blockchain. And in future, if we get time, then we can describe these things. How can we develop? So you need to learn some language to develop blockchain application. Yes, Amar. Hello.
Yes, Dr. Ashraf, yes.
Yes. So please click, for example, you need to know the Solidity language. If you click, then you can know how this language works, and you will have some idea which editor we should use. For example, we can use the Remix editor.
Yes.
Or maybe we can use the Visual Studio Code. And you need to learn the React to develop the user interface. To develop the smart contract, you need to learn the Solidity language. And next, we need to learn the Web3 language to develop the application. In this example, here is a link of an example YouTube video. You can watch this video to develop your own application. I think he describes everything in detail for developing a decentralized application. And this is all for this lecture. Maybe if anyone has any question, then Amar, can we give them just 5 minutes if
Yes,
they
yes.
have any question?
If you have any questions, students?
Any question about blockchain?
Anyone would like to ask a question?
So anyone? Anyone has any question, like how blockchain works?
All good, sir.
Yeah, thank
All
you.
good,
For,
okay.
yeah. So, Dr. Ashraf,
Okay,
yeah, thank you for this presentation. It's very great. So, do I need to upload the lab 12 on the model, or what do you think? Because normally there is no lab 12. Like just we are doing review.
Maybe for not this.
Yeah, maybe
semester.
not for this semester, maybe for the next semester, because you know, like we do have another 3 tutors because maybe they're not prepared as well for this lab. Yeah, because it's very hard because we have Vanood from Sydney and we have Dr. Ansam. Maybe they are not prepared even for me.
Yes,
but,
sure.
But we can do it for the next semester, Dr. Ashraf.
Yes, next semester, and thank you for
but if feel free to share this one with your student as you like. It's up to you for your students.
Yes, sure.
Yeah, I'm not sure for me. Yes, thank you, Dr. Ashraf. I will end this meeting.
Okay, thank you.